Hey guys, this is Mr. Anziano, picking right off where Mrs. Keener left off in her video for part 1 of the Unit 6 test review. So from that video, Mrs. Keener pointed out that the answer to the first question, where they were asking us after how many hours the initial population has tripled, we ended up getting that time, t, was equal to 15.852 hours. And then we started answering the next question where it says how many bacteria are in the dish after 22 hours. And so the way we do that is by simply plugging 22 in for t right into our equation. Okay, so we're looking for B of 22, or the number of bacteria after 22 hours, right? And that's going to be equal to 250, which is what we started with, times e to the 0.0693 t. But t is actually going to be replaced with 22, right? So really, that's just 250 e to the 0.0693 times 22. And let's see what happens in a calculator. 250 times e to the power of 0.0693 times 22 is 1,148.3 bacteria. So do we need to round this number? Can you have 0.3 of a bacteria? I would say let's go ahead and just give the full answer and perhaps have a class discussion on what's more appropriate. 1,148.33 bacteria after 22 hours. All right. So that's it for number 8. Moving on then to number 9. Number 9 is asking us to order the expressions log base 20 of 4, 2 times the natural log of e to the negative 3, and e to the power of negative 2 natural log 4 from least to greatest. And because we're allowed the use of a calculator, I'm going to go ahead and take advantage of that. Could you order these without using a calculator? Perhaps. But because they're allowing us the use of a calculator, why not use it, right? So first, let's see, log base 20 of 4. That means what do we raise 20 to the power of to get 4, right? And using a calculator, we can just use our change of base formula, right? Because our calculator operates in log base 10. So we're going to do log of the argument divided by log of the base. And we get 0.4628 is what that's going to round to. Okay, moving on. The next thing we need to calculate is now 2 times the natural log of e to the negative 3 power. Again, this one would be a little bit easier to do without a calculator, because really the natural log of e to the negative 3 is simply 2 times negative 3, right? So really we know that that's going to get us negative 6. And it does. So 2 natural log of e to the negative 3 equals negative 6. And finally, e to the power of negative 2 natural log 4, really we can kind of predict we're going to move that negative 2 up into the exponent, right? And we're going to get then e to the natural log of 4 to the negative 2. So really e to the natural log of 4 to the negative 2 sounds like a lot of crazy stuff, but that's just going to turn into 1 over 16. And let's see if the calculator can verify that for us. E to the power of negative 2 times the natural log of 4. What do we get? Ooh, we get 0.0625. Calculator actually has a cool function where I can go to math and then turn that number into a fraction. And check it out, we get 1 over 16, just like we expected. So e to the negative 2 natural log 4 is equal to 1 over 16, which is really just 0.0625. All right, now we need to order these though, right? So the smallest, or least I should say, to greatest, the smallest number, the number to the left, the most left on the number line is going to be negative 6, right? Although it's a big integer, the fact that it's negative means it's a small number, right? So really the order is going to look like this: 2 natural log of e to the negative 3. Oh, lost my lights. I think we can still see. 2 times the natural log of e to the negative 3, followed by the next biggest number is going to be actually 0.0625 is just a little bit smaller than 0.4628, because this really is close to 1/2, right? 0.5 would be 1/2, or 0.5000 would be 1/2, and this is 1/16th, as we know. So the next one is e to the -2 natural log 4, which is then followed by log base 20 of 4. So that's your order from least to greatest. Okay. Next, calculator, the solution to the equation 3 to the 2x equals 5 to the x minus 1. And they're asking us that to find where x lies between. Which two integers does x lie between? Okay. Well, I'm going to solve this algebraically until I can't anymore, and at that point I will then use a calculator. Sound good? Let's do that. All right. Because there's not a common base on both sides of this equation, I need to use the natural log. So I'm going to start by taking the natural log of 3 to the 2x and setting that equal to the natural log of 5 to the x minus 1. Okay, then that allows me to move my coefficients into the, my exponents into the coefficient, right? Kind of just like that. All right, so now we have 2x natural log 3 equals x minus 1 natural log 5. Okay, and at that point we then get 2x natural log 3 is equal to, I'm going to distribute that x minus 1, both of them, into the natural log of 5. So really this is going to turn into x times the natural log of 5 minus 1 times the natural log of 5, which is just natural log of 5. Okay. Now, really what we want to do here is actually combine the terms containing the variable x so that we can then factor it out. Okay, so really I'm going to move this term right here, this x natural log 5, I'm going to move that to the left by subtracting. So I'm going to have on the left hand side 2x natural log 3 minus x natural log 5 is equal to negative natural log 5. Don't forget to keep that negative right there with it. Okay, then we'll bring it over here. Now we have that x is going to come out of the two terms containing an x on the left hand side, and we're left with then x times 2 natural log 3 for that 2 right there, and then minus, we don't have any coefficient in front of the x there, so really that's just going to be minus natural log 5. I'm going to close the parentheses off, and then that together is going to be equal to negative natural log 5. All right. Next, we're really close. We almost have x by itself, but now I need to divide both sides. I'm going to divide both sides by that big natural log term. 2 natural log 3 minus natural log 5. I'm going to do that over here as well. Kind of running out of room there. But in the end, we end up with x is equal to negative natural log 5 in the numerator divided by 2 natural log 3 minus natural log 5. And that I'm then going to plug into my calculator. All right, technically I could probably split this up into two. Just kidding. No, that's about all I can do. That's all we can do. So let's see what the calculator gives us. We've got negative natural log of 5 divided by parentheses, because we have two terms, 2 natural log 3 minus natural log 5, and close off that group, right? And we end up getting negative 2.738. Remember, the question was asking us between which two integers does x lie, so really that's between negative 3 and negative 2. Okay, so we got a real solution for x, but they're also asking us to find which two integers x lies between. So the closest ones would be -3 and -2, but a little bit closer to -3, right? Because it's -2.7. So, moving on to number 11 then. We're at 10 minutes already. Shoot, we gotta get going. There will probably be another couple videos coming out. So let's just keep moving right along. Number 11 is asking us to solve for x. Looks like we're probably going to be combining these separate logarithms into one and then solving for x from there. So let's do that. First of all, we have log of 7 minus x minus log of 3x plus 2 turns into log of, remember the base 10, right? If there's no number there, the invisible base is 10. So that turns into log of 7 minus x over 3x plus 2. And we know that that's equal to 1. So really what this is now stating is that 10 raised to the power of 1, right? If you wanted to, you could certainly write that in just to make sense of this. 10 raised to the power of 1 is equal to the inside of the logarithmic argument, right? So really we have, our next line is going to look like 10 to the 1 equals 7 minus x over 3x plus 2. Okay, so how am I going to get x by itself? Well, first thing I want to do is multiply both sides by 3x plus 2. So I'm going to take 3x plus 2, multiply it there and also over here. And it goes away on the right hand side, and on the left we're left with 10, because 10 to the 1 is just 10, times 3x plus 2 equals 7 minus x. Let's bring that right up here. Oops. Okay, so we end up with 30x plus 20 is equal to 7 minus x. Combine like terms, I'm going to move the 1x over here to the right, and I'm also going to subtract 20 from both sides. So I end up with 31x is equal to 7 minus 20 is going to get us negative 13, right? Divide both sides by 31, and we get x is equal to negative 13 over 31. Okay, and rather than moving on to the next problem, I'm going to stop here, and I'm going to show you guys how we can verify that negative 13 over 31 is in fact the correct solution. Okay, so let's actually get a Desmos tab going. I'm going to pause and unpause. Here's Desmos. So remember, we were going to go ahead and verify that negative 13 over 31 was the correct answer to this situation. It was the correct value for x. Also, we need to figure out really how many solutions that is, but we can see that it's clearly just one, right? Negative 13 over 31 is just one value, if we did it correctly. So let's check. On Desmos, what I'm going to do is I'm going to set one of my equations in one of those boxes equal to the left-hand side of this equation. Okay, and then I'm going to set the other side, I'm going to make a function where y is equal to simply 1. So we have y equals, looking back at my paper, I have log of 7 minus x, and then minus log of 3x plus 2. Okay, and just to be safe, I'm also going to put the graphing calculator knows what I meant, right? Oh, I did put a y equals. I thought I didn't for a second. All right, so we get that logarithmic looking graph right here. Okay, well, sort of logarithmic looking anyways. The next function we're going to create is y equals 1. And we're going to see if those guys meet at exactly negative 13 over 31. It looks like they intersect right there at negative 0.419. I don't know if that's negative 13 over 31, but let's find out. Negative 0.419 is in fact equal to negative 13 over 31, so we know that because those graphs intersect right at that point, that negative 13 over 31 is good. So that was our value. We ended up with just one solution, and that's the end of page 2. Woo! All right, keep posted for the rest. Have a good one, guys.